Hello viewers, today we're actually going to look at our lesson number 5, where we're going to look at addition and subtraction. So it's actual continuation of number bases. So we are going to actually take note of some notes that are actually important when dealing with number bases, addition and subtraction. So the first point that is very vital is whenever when you're adding, right, or subtracting number bases, right, you have to make sure that they are under the same base, right? So this is quite important. Whenever you're adding numbers in different bases, you have to make sure that you put them first under the same base. So let's look at example number 23, which says simplify 20 base 5 plus 11 base 5. Now the first thing that you have to take note of is, are my numbers under the same base? Yes, then same base. Then I continue, right? So it's going to be, so I'm going to illustrate method A, right, which is the shortest method. Then later on I do method B, right? So method A is actually, I'm given under the same base, so I can actually calculate it and leave it in base 5, since I haven't yet thought to put into another base. So I'm going to leave my answer in base 5, right? So I do this 20 base 5, sorry, plus 11 base 5. Then I'm going to say 0 plus 1, right? Whatever I get, remember, whatever I get, so 0 plus 1 is a 1, right? Then I divide it by the base, right? So I have base 5, so I say 5 into 1, it's 0. The number that 5 gets into 1 is what I'm going to carry, so it's going to be 0. Remainder 1, what is written here is the remainder. Remember, the remainder is actually the most important thing when you're dealing with number bases, right? So I go to my next digits. 2 plus 1, that's a 3. I say my base 5 into 3, 0, remainder 3, right? So I write my remainder. So we have been doing this all along in the dinar system. For example, let me show you, right? Let's say if 21 being added to 11 and a base 10, like what we've done, it's 1 plus 1, then we say 2 plus 1 is what? Is 3, right? So let me show you. 1 plus 1 is 2, then I write my 10 there, since it's beside is in base 10. So 10 into 2, that's 0, remainder 2, I write my 2. We do the same thing. 2 plus 1, that's 3. 3 divided by the base 10 is 10 into 3, the 0, remainder 3, right? Then I write my remainder. So this is how we've been doing all along in the dinar system, right? Let's look at method B. Method B, actually you convert everything to base 10. So I'm going to convert 20 base 5, right, to base 10. So now this, remember in the previous lesson we said is 2 times the base plus 0 times the base. I write my powers, right? So it's actually going to be first power 1, that's 5 times 2, that's 18, plus 5 power 0, that's 1, times 0, that's actually a 1, right? It's going to be an 11 there. Then I do the same thing for 11, right? 1 times 5. I'm going to do this one quickly, right? So you saw my 5 is not actually visible. Let me write it down. 1 times 5, then that's 0, this 1, so it's going to be 1, 5 to the power 1, that's 5. 5 times 1, that's a 5. here 5 to the power 0, this 1 times 1, this one is going to be a 6 there, right? So then I add, right? So I'm going to add 11 plus 6. So 11 plus 6 is what? It's saying 11 plus 6, it's 17, right? Base 10. Then I change it to base 5. Remember what we said when I changing a number from base n to from base 10 to base 5, right? So I'm going to change my number, is going to be 17, then my remainder here. So 5 into 17, that's actually 3 times remainder 2, then 5 into 3, that's 0, remainder 3, then I write it going upward. So the answer is going to be the same, but it's absolutely long, as you have seen here. So I actually advise you to do method A, or to use method A actually under exam condition. So let's look at example 24. Simplify 1 base 2 plus 1 3 base 4. Leave your answer in base 2. So what they're actually going to do is to convert this 13 base 4 to base 2. So remember, we're going to move from base 4 to base 10, then base 10 to base 2. We don't have a direct method under O-level syllabus that actually specifies to move from base 4 to base 2 directly. So here I'm going to convert 13 base 4 to base 10, right, which is equal to 1 times 4 plus 3 times 4, that's 0, that's 1 there. So I'm actually going to get something like 4 to the power 1, that's 4 times this one, that's 4. 4 power 0, that's a 1. 1 times 3, that's a 3, which is going to be a 7 base 10. Then I change this base 10 now to base 2, right? So I write my table. I want to change it to base 2. I have a 7. I write my remainders here. 2 into 7, that's 3 times remainder 1. 2 into 3, that's only once remainder 1. 2 into 1, that's 0, remainder 1. Then I write it. That's so it's actually like 1 1 2 plus 1 1 2, right? Now let's add 1 plus 1, that's 2, right? Then I divide by the base. 2 into 2 is 1, remainder 0. So I write the remainder, then I carry what actually was the number 2 goes into 2, right? Now we move on. 1 plus 1, that's 2 plus 1, we have carried, that's a 3. Then I divide it by my base, it's actually going to be 1, remainder 1. I write my remainder, I write the one number here. I do the same thing. 1 plus 1 plus 1 is 3. I divide it by the base, it's 1, remainder 1. There's nothing here to add, so I just write the last one number, which is 1. So don't forget to put your base. So remember, the reason why we're doing this is to make sure that whenever we look at numbers individually, there's no number that is going to be bigger than the base. So we have to take note of that idea. Right, let's look at example number 25, which asks us to simplify 1 base 2 minus 1 base 2. Now 1 minus 1, that's a 0, right? 0 minus 1, it can't. So what do? We add base. Wait, please, we add the base. So what is the base here? That's 2. So I'm going to add 2 here. Wait, then I add a 1 in it there. 2 minus 1, that's a 1. 1 minus 1, that's a 0. 1 minus a 0, that's a 1. So my solution is 1 0 1 0. Right, someone might say, why are we adding base 2? Let me take you back to when we're dealing in base numbers in base 10. Let's say I have 10 in base 10 minus 9 in base 10, right? We used to say 0 minus 9, it can't. Then you add 10 here. So then you put 1 in. So what was the 10 that we're adding here? It was the base, right? So whenever when we're adding a 10 here, it was actually coming from a base. So it was 10 plus 0, that's 10. Then you now subtract. So that's the same thing that we did here. 0 minus 1, it can't. So I add a base. So I'm now saying 0 plus the base 2. The answer becomes 2. Then I subtract to change that improper subtraction that was there. Right, so let's look at example number 26, which asks us to do that example of 213 base 8 being added. Right, now let me just change this addition sign and put a minus there. Right, since we've done a lot of questions under addition, right? So let me rub it. Right, so 213 base 8 minus 2 3 base 5. The saying they asked to leave the answer in base 8, right? Base 8 there, right? So let's do that one together. Now we want to leave the answer in base 8, right? So the first thing that we have to do is to convert 23 base 5 to base 8, right? So 25, sorry, this 23 base 5, right? It's actually going to be 2 times 5, then plus 3 times 5. Remember, multiply every number by the base, then you put on the power starting from the right hand side, the 0 1 there, then you're going to get a 10 plus a 3, which is 13. Then you put it to base 8, right? So 13 to base 8 to write our table, right? So 8 into there, there's 1, remainder 5, 8 there, there's 0, remainder 1. Write it from bottom to top, right? So it's going to be 1 5 base 8, then you add it, right? So now it's going to be 213 in base 8 being subtracted, so we're going to subtract 15 base 8 from 213 base 8, right? So now 3 minus 8, it can't. So what do? We add the base, right? So that is the reason why we're saying whenever you're adding or subtracting, make sure the bases are the same, because remember, when you don't have some bases, what are you actually going to add here, right? So it's going to be difficult for you. So please make sure the bases are the same. So 3 minus 5, it can't. I add my base is 8, I add it to 3, I'm going to get an 11 here, then I add 1 unit there. 11 minus 5, it's not going to be something like 11 minus 5, it's the man just stuck there. It's actually simply white, it's actually 6, right? That's called breadfish. 1 minus 2, that's, it can't, so I add my base 8, I add it to 1, this becomes a 9, then I add 1 into the 1, 9 minus 2, that's a 7, then 2 minus 1, that's a 1. So there goes your solution. Do exercise 1G by yourself and try to get the solutions correctly. Any question, please put it on the comment box. See you on the next lesson. Thank you.